Good afternoon, mathematicians, and welcome back to part 2 of Miss Granton's video on chapter 7.5, factoring polynomials of the form x squared plus bx plus c. So for a quick review about factoring, we are taking something and breaking it down. For example, if we had a square or a rectangle, and we decided to divide that shape into two pieces. One piece would be this piece in blue, which, if you look closely, makes a triangle. And the other part would be this piece in red, which also makes a triangle. So we took an original shape, like a square or a rectangle here, and we broke it down into its pieces, or its component, or its factors, which were the two triangles there. So that is what we are doing, except with polynomial expressions in a more algebraic way. So let's get to an example here. And again, just a reminder of the objectives. X squared plus bx plus c is the main polynomial case that you will be learning about here. And once you learn how to do that, you will be able to factor the remaining three cases. So let's get to an example. Let's say that we want to factor the polynomial x squared plus 8x plus 7. So when we factor a polynomial, we know that we are going to have parentheses like this. And inside each set of parentheses, we are going to have two terms, also known as a binomial. And remember that terms are separated by either addition signs or subtraction signs. Now, as some of you may remember, I prefer to always separate my terms with addition signs, even if that means we end up adding a negative number. So the first thing we want to look at is the number at the end, which is also known as the constant term, the number without the variable. So look at that number and think about the factors of that number. What are the factors of 7? Well, I can think of 1 times 7, that gives us 7. Is there anything else? I think that's it, because 7 is prime, so that makes sense. Now, if we multiply 1 times 7, we get 7. What happens if we add 1 plus 7? What is that? It's going to be 8. And notice that 8 is that term in the middle with the x, also known as the linear term. That actually is what we want to be doing this whole time. We want to find factors of our c, or our constant term, and then we want to make sure that those same numbers add up to our middle term. So now when we go to factor, well, we know we can put 1 here and 7 here, but what goes right here and right here? Well, look at the first term of your trinomial, it's x squared. And if we don't see a number in front of the x squared, what number do we know is the coefficient? That is a 1. And what are the only factors of 1? 1 and 1. So the only way to get x to the second power is to multiply x times x. Now, let's multiply this entire expression out using FOIL, which I reviewed in part 1 of this video, and then see if we get this expression back. If we do, then that means that this is the correct factoring. So let's do it. Let's use our FOIL method. So we know FOIL, F was for first, O was for outer, I was for inner, and L was for last. So I'm going to start a new page here, but I'm going to transfer over this factoring to see if it works. So we have quantity x plus 1 times quantity x plus 7. Okay, so let's see. Using FOIL, this is first. We have x times x. And what is that? X squared. Okay, looking good so far. Next we have O for outer, so we have x times 7. X times 7. What is that? 7x. Next comes I for inner. We have 1 times x. What is 1 times x? Good, 1x or just x. And finally we have L for last, so that's 1 times 7. And what is that? 7. Okay, so now let's see. We have x squared plus 7x plus x plus 7. What are our common terms? Well, I see a 7x and I see an x or a 1x. What do those make? Yes, they make 8x. So this is x squared plus 8x plus 7. Okay, does this expression that we just found right here match our original expression right here? Let's see, let's compare. Looks good to me. It looks like they match. So therefore, we know that this factoring right here is the correct factoring, and that would be the answer to this problem. Okay, let's do another example. Let's do one where the term in the middle, also known as the linear term, is negative. Okay, so this time, let's go ahead and do, how about n squared minus 13n plus 22. Okay, so again, the middle term, also known as the linear term or the b term, is negative. Okay, so first things first, I'm going to create my setup with two binomial expressions separated by addition, even if it means we add a negative. I know right away as well that the n squared right here, also known as the a term or the quadratic term, remember that coefficient is a 1, and I know that the only way to get 1n squared is to multiply n times n. That will give me back n squared. Okay, so I know that's the only option for that. So now I'm going to focus on the 22 at the end, the constant term or the c term. So what are some factors of 22 that also add to negative 13? Well, let's see. Factors of 22. How about 11 times 2? If we add 11 plus 2, what do we get? We get 13. That's very close. The only problem is that we want a negative 13. So how else can we get a positive 22? Can we maybe make the 11 and the 2 negative? Well, let's try that. Negative 11 plus negative 2. That gives us negative 13, which is what we want right here. So that means that the two numbers that we should choose for these spaces right here are negative 11 and negative 2. Okay, now let's use the FOIL method to check if this factoring makes sense and is correct. So let's go to the next page for that. So we have n plus negative 11 times n plus negative 2. And if you don't like the plus negatives, remember that you can also write this as n minus 11 times n minus 2. Okay, so let's go a little bit faster through FOIL. Remember, F stands for first, so n times n equals n squared. Next is outer. We have n times negative 2. That is negative 2n. Next is inner. Negative 11 times positive n. That is negative 11n. And finally, last, we have negative 11 times negative 2. That is a positive 22. Searching for like terms, we have negative 2n and negative 11n. And if we combine those, what do we get? Negative 13n. So we have n squared minus 13n plus 22. Now, does this expression right here match our original expression right here? Yes, it does. So that tells us that this factoring is the correct factoring, and that would be our answer. So in part 3, I will do 2 more examples. One of them will be where the constant term is negative, and then another example will be where both the linear term and the constant term are negative. Stay tuned.